Hey Mustangs, it's Miss Sigmund here coming at you with another geometry video. This time we're doing lesson 3-5 on symmetry, which is not a new concept to us. We've been doing symmetry, we've been finding like the symmetry since what? First grade? Kindergarten? We know what symmetry is, so take a look at this. Here's our explore problem. What we're going to do is we're going to look at how pieces A and B are related. We've gone through all of these types of transformations now. We've talked about reflections, we've talked about rotations, we've talked about translations, and then we combine them all together. And so if we look at this, what's happening in the shape to create this nice symmetrical kind of kaleidoscope type image? So how are pieces A and B related? So let's look closer at piece A and piece B. Piece A looks like it comes from just like a sliver right here of this flowery kaleidoscopy shape. And piece B looks like it's half of that. So piece B appears to be half of piece A, and if you reflect piece B over its horizontal side, so if we're going to reflect B over its horizontal, that would make piece A. So we're going to have a reflection, there it goes, boom. Describe a sequence of rigid motions that you could use to put piece A to produce this image. So I'm going to take piece A and I'm going to put it back into here, and then what am I going to do? Well, I'm going to rotate it and then rotate it again and then rotate it again and rotate it again. I could also maybe do a rotation and then a reflection to get it around. So I'm going to rotate that pointy end, looks like 45 degrees to me, all the way around. I could also do rotate, reflect if we wanted to. How many rigid motions did you need to produce the image from piece A? Can you think of another set of rigid motions? We just answered that. Piece A needs to be rotated 7 times to produce the image. You could also reflect piece A 7 times across either of its straight sides to produce its image. How fun. So we got some words here to know. You have guided notes that you're filling out in front of you. If you don't have your guided notes, you're writing these down on your own piece of paper. If they're important enough for me to type up and talk about, they're important enough for you to write down. So this idea of symmetry is a figure that has symmetry, has rigid motion that can map it onto itself. So we have a symmetrical figure here, and this one has a reflection that we can use. This one is asymmetric because it does not have the same shape on both sides. We know this. Some symmetrical things look nice and asymmetrical things don't always look nice. Okay, reflectional symmetry means that a symmetry for which reflection maps the image onto itself. So if I was to fold it in half, it would look the same on one side and the other. This is also called the line of symmetry. The line of reflection is the line of symmetry. You've been drawing these for a long, long time. This is not a new concept. Okay, rotational symmetry is if I can turn it and it looks the same. Boom. So I could flip this one 180 degrees and it would be the same shape on it. So this has rotational symmetry. We'll dive into rotational symmetry just a little bit more in a few minutes here. And then we have point symmetry. And point symmetry is a type of symmetry which there is a rotation of 180 degrees that maps it onto itself. So if specifically its angle of rotation, its rotation symmetry is 180 degrees, then it also has what's called point symmetry. So we're going to work our way through these problems right here. And you can see on your guided notes, we have a bunch of examples here on the next 2 pages for us to talk about different types of symmetry. So let's do it. Example 1, what transformations map each figure onto itself? What type of symmetry does each figure have? So I'm going to look at this and I'm going to say, okay, what transformations match each figure onto itself? Well, I can see that right here, I could fold it in half. A reflection over the vertical line through the center or the horizontal line through the center. So the horizontal line, vertical line, or I could flip it 180 degrees and it would be the same. For the little smiley face here, it just has reflection through that vertical line and down the middle. Okay, I can only fold it in half once. And that would give it that. So the little plus sign here has reflection symmetry and rotational symmetry, and also point symmetry because its rotational symmetry is 180 degrees. This smiley face guy only has reflection symmetry through that center line. Okay. Right here, we're going to identify the different kinds of symmetry. How many lines of symmetry does a regular hexagon have? And we're going to draw them on your paper. So you're going to draw them down on your notes. Here we go. So the first one I see, we can cut through this vertex. Right here we go from one corner to another corner. If I cut that, there is a line of symmetry. Well, if I could cut it here, I could also cut it here, and I could cut it straight across the middle. So total brings me to 3 lines of symmetry through those corners. Okay, but what happens if I cut it down the center? Can I cut it down the center? Yes, and it still stays symmetrical on either side. I could fold it down the center, and we would have the same shape on either side. So if I could fold this line, I could also fold this line and fold that line. So we have 3 lines through opposite vertices, 3 lines through opposite sides. 3 plus 3 is 6 lines of symmetry total. There they are. That looks so beautiful. So for here, go ahead, give it a shot. Pause the video, draw your own lines of symmetry on each one of these shapes. Hopefully you did that. Here we go. I drew that line first. I said, ooh, that has horizontal symmetry. And then I said vertical symmetry. Does it have symmetry across the axes? I didn't think so. So total 2 lines of symmetry on this rectangle. This trapezoid guy, I thought maybe this one looked like the one that jumped out at me. If I cut it the other way, doesn't really look symmetrical. So I just gave it 1 line of symmetry. There it is. Okay, for this one, now we're going to look into that idea of rotational symmetry. And sometimes it can be hard to think about, but if you actually physically turn your paper on the table in front of you, if you're actually turning that paper, you can kind of see what's happening here. So I think I have a turn. So what we need to do is find those angles of rotation. If I turn this, so if I turn this shape so that B is on the top next, will it look the same? And it turns out it will. So take a look at this. As I turn this shape over, as I turn that shape around, do you see what happened there? Do you see what happened as I turned it around? So there at C, it matched up. And I can turn it all the way around. So notice that angle of rotation that's happening in the middle. I've got the same shape, and I'm turning. When I hit 120 degrees, what happens? Well, the shape is the same exact shape as my original shape. Now I'm going to keep going. I'm going to turn it again. I'm going to turn it again, turn it again, turn it again, turn it again, turn it again. And what's happening there? I can't get it. There it is. Okay, I turned it. Now I'm at 240 degrees. I've turned that shape around, and now I'm at the same place I was before. Now C is on the top, but it's the same shape. It looks the same. So that would give me an angle of rotation of 120 and 240. I can keep going all the way around again. I got to 360. So that angle of rotation there is going to finish the video. The angle of rotations would be, let's see, why is it still going? 120 and 240. Everything has 360 degree symmetry, so it's not interesting that I write that down. So this has rotational symmetry of 120 degrees and 240 degrees. And that's how we kind of figure it out. What happens when I turn this shape? So let's do another example here. We're going to find the angles of rotation for this guy. So I've got my video here. We're going to start to turn it. I've got the little slider that turns it. So we're turning. Once I get to 180 degrees, there it is right there. Let's pause for a second. Go back. 180 degrees is what the angle of rotation needed to map it onto itself. So the shape is now the same 180 degrees. Okay, we're going to keep going, all the way around to 360. So this one only had one thing. It has 180 degree rotational symmetry, which means that it has point symmetry. Ready? Let's see if I can go. Okay, so here's example 3. Give it a shot. Pause the video. What are the rotational symmetries for each figure, and how does each figure have point, and does it have point symmetry or not? So hopefully you paused and you thought about it. When we look at this, as we turn it around, this looks like a 90 degree turn, 90 degree turn, 90 degree turn would make it the same shape. So it would have 90 degrees 180 degree and 270 degree rotational symmetry as I flip it around this way. And because I have that 180 degree rotational symmetry, it has point symmetry. This guy here just has 180 degree rotational symmetry. I just flip it over, flip it over, flip it over, which means it has point symmetry. Okay, the last kind of example we'll look at is what happens when things have multiple kinds of symmetry. So take a look at this beautiful purple flower. We're going to describe what type of symmetry this figure has. So I'm going to look at it, I'm going to say, okay, I see this line of symmetry through the middle right there, and if it has that line of symmetry, it also has this one, and this one, and this one, and this one going all the way around, for a total of 5 lines of reflectional symmetry. I could fold it across each one of those petals, and we would keep it the same. Okay, so now let's think about that rotational symmetry. The rotational symmetry happens if I turn the flower over, and you can kind of see that if I go from here to here, that petal would become this petal will come up, and so what I'm going to look for is how far over did I go? Well, if I'm going 5 things around to get back, 360 divided by 5 will give me 72. It turns out that that angle right there is 72 degrees. I'm going to go 72 degrees again, 72 degrees again, 72 degrees again, 72 degrees again, all the way around that shape. So I have rotational symmetry of that 72 degree stuff happening all the way around. And so how I would find those degrees of rotation is I would say 72 would be my first one. That would get me to here. Then 72 plus 72 would be 144. That would give me to the second rotation. Actually, this guy right here. And then I would add 72 again to get 216, and again to get 288, and then that would be all of the ones that I have. So this would have rotational symmetry at 72 degrees, 144 degrees, 216 degrees, and 288 degrees. And that's kind of the process here and how I would find that rotational symmetry and those exact angles. Because I didn't hit 180, this does not have point symmetry. Okay, so here's 2 for you to try. Example 4. What type of symmetry do these shapes have? Pause the video, give it a shot, give it a try. Hopefully you did that. Here we go. So if I look at this, can I cut this vertically? No, I would say no lines of symmetry can be drawn. If I cut it here, like this red dot should line up with that, and there's no reflection symmetry in this shape because of these red dots. If these red dots weren't there, there would be lots of different choices. But right now, as it is, those red dots kind of keep us from having reflection symmetry. Okay, rotational symmetry. If I turn this 180 degrees, that dot would come to here. Okay, so I would say it has 180 degree rotational symmetry, which is point symmetry. Okay, how about this square? Lines of symmetry. It has 4 lines of symmetry. 1, 2, 3, 4. And rotational symmetry, 90 degree corners. If I turn it 90, turn it 180, turn it 270. Very similar to that little star that we did a few minutes ago. That would give us rotational symmetry because it has 180. It does have that point symmetry as well. Okay, that brings us kind of to the summary. We talked about reflectional symmetry and how we see that with kind of where can we fold it to map it onto itself. And we talked about rotational symmetry. It has to be less than 360 because everything has 360 rotational symmetry, and that's boring. Anything with 180 degree symmetry, we get to say it has point symmetry. We went through that process on how to find that. So now it's up to you. Head over to Math Excel, give it that practice homework, some practice, and then take that lesson quiz. Make sure you're reaching out to your teachers if you have any questions, problems, issues, or concerns, and we will see you again in class soon. Have a great day, Mustangs.